So after seeing what is mean by rate of reaction, okay, we have seen the definition. Now let's move on to the next one, that how to measure this rate of reaction practically. Okay, because we have seen what is mean by rate of reaction. So rate of reaction means at what rate either the reactant is getting consumed, okay, or at what rate the product is getting produced. Simple. Okay, that we are seeing. But now let's see practically how we are going to do that. So one of the methods is to measure how much product, one of the products is getting produced. Okay, so let's take this reaction, which is you are quite familiar with. That is a calcium carbonate, that is our limestone basically, is being reacted with hydrochloric acid. This is our acid, HCl. And during this reaction, what is important is that there is a gas of CO2, carbon dioxide, which is getting produced. So what we are going to do, we are going to measure this, how much CO2 is getting produced, at what rate. Simple. Okay. So let's understand this, what is the experimental setup. So there is a conical flask. This is a conical flask in which we have taken calcium carbonate pieces, limestone pieces, and we have put HCl. Okay. So as you can see from this reaction, as the reaction starts, the carbon dioxide will start getting produced. Okay. So here comes the CO2. And obviously CO2 will pass through this tube. Okay. And finally, it will reach here. Then it will get bubbled through this water. Okay. And it will start coming here in this phase. And depending on as the CO2 getting produced more and more, it will start pressurizing this. It will start pushing down this water, and you can measure this from the measuring cylinder. How much volume of CO2 is getting produced. Is this procedure clear? Let me repeat. So we have taken a conical flask. Okay, this is a conical flask, what we have taken. Then we have taken HCl and calcium carbonate limestone pieces in it. And we have connected through the delivery tube to this measuring cylinder, which is immersed in the water. Okay. So as the reaction proceeds, okay, the CO2 will start getting produced, and that we are collecting in this measuring cylinder. Okay. And this is basically the experimental setup. So what we are basically measuring at various time intervals, how much CO2 has been produced. Okay. So let's see now what kind of this one, how we can measure. So you can clearly see on this graph, okay, this is the graph of volume of CO2 produced versus time. Time can be in seconds or minutes, depends on this. So you will get such kind of a graph that initially infuse this one, first CO2 will get produced. Okay, the rate will keep on increasing initially up to this. Then after that, it starts getting flattened down. Okay, and finally, it just settles down. That means the reaction has been completed. Okay, nothing can be produced. No CO2 will be produced. So this is the maximum. Okay. What is the maximum CO2? And based on this, you can find out basically the rate of reaction. Okay. So how we are measuring the rate of reaction? By checking at what rate the product, one of the products, that is in this case CO2 gas, is getting produced. Okay. So now let's see how we can find out. So what you can do, there are two methods. Okay. Either you can find out the average rate. So how to find out the average rate of reaction? You find basically what is the change in the volume over some interval. Change in volume of CO2 divided by time. Let's take the example. For example, if we pick up this time interval, okay, I'll call this a T1. And let's say another interval time T2. Okay. And you find out corresponding what are the volumes. So I'll call this as V1 and this as V2. Okay. So in short, if we find out this gradient or the slope of this chord, slope or what we call gradient of this chord, we will get average rate. Okay, it is very, very simple technique. You find out for the given two time intervals, okay, T1 and T2, you find out the corresponding slope of the given chord, okay, and that will give you the average rate of the reaction. Simple. Hope this is quite clear to you.